Very good morning to all. I'm Sathish Kumar, Assistant Professor in AIML Department, working at RMDEC Engineering College. In this session, we're going to discuss about pipelining in Unit 4, Basic Processing Unit and Pipelining. In this Unit 4, pipelining is the important concept. Let me discuss about pipelining. Before that, we're going to see about non-pipelining instruction, how non-pipelining instruction are carried out by the processor. If we know about a non-pipelining only, we can able to understand what is pipelining. How instructions are handled in pipelining. What is the difference? We can able to understand it. In this diagram, we have 4 instructions. That means 4 instructions carried out by non-pipelining processor. So each instruction has 5 stages. That means each instruction going to perform the fetch the instruction, decode those instruction, and finally execute based upon the instruction operations. And finally, it may utilize the memory also some cases. Finally, it may store the result in the memory itself, that is write back. So we have 5 stages should be carried out by each instructions. And in this case, non-pipelining instruction, we have 4 instruction. Each instruction will be carried out after the previous instruction get completed ended. Instruction 2 will be started after completing the instruction 1 completely. Similarly, instruction 3 will be started after completing instruction 2. Instruction 4 will be started after completing the instruction 3. So that each instruction must perform those 5 stages. Each instruction carry out one cycle for each 5 stages. So that what will happen? Means to complete this 4 instruction, we need minimum 20 clock cycles. As well as here no overlapping method. That means instruction cannot be handled simultaneously. So that here multitasking is not performed here. So this drawback has been eliminated in pipelining. If you consider each cycle is 15 milliseconds, that means to execute this 4 instruction, we need minimum at least 300 milliseconds to execute those 4 instructions itself. Let me discuss about pipelining. In this diagram, analyzements, we have various colors are indicated for those 4 instructions. Here also we have taken those 4 instructions as well as each instruction going to perform these 5 stages: fetch, decode, execute, memory, and write back. In this diagram, analyze means each colored box is very closer or even very closer to each other. But each instruction, this is the instruction 1. In this instruction, we're going to perform fetch phases, decode phases, fetch cases, decode phases, and execute phases, and finally write back. Fetch, decode, execute, memory, and write back. Once it perform instruction 1 finish the fetch phases, it moves to decode phases. That means decode stage. Once it in decode stage, the instruction 1 fetch is free, so that it may handle the instruction 2 in fetch stages. Similarly, after completing this decoder, move to execute phase. This instruction 2 will move to decode phase. It going to handle instruction 3 fetch stage. So it gradually increasing the stages. After completing one stages, it moves to next stages. Next instruction can be handled simultaneously. So that what will benefit obtained is reducing the number of cycles, total number of cycles to complete this 4 instruction, as well as simultaneously we handling the instructions, so that multitasking is obtained here, so that overall performance can be improved. Assume that if you have each cycle is 15 million seconds is taken for this four instruction. For this five stages means we have just have 120 milliseconds only. Compared to non-pipeline, we have 300 milliseconds, but in this case 120. So the time consuming is very less in this case. So that performance is improved by handling the instruction and pipelining. Thank you.